3 is the one that has R equal to the set of all numbers from 1 to 100, and T is the set of A, B, C, where A is less than B and A is less than C. Okay, we can look at that one. So let's write it down real quick. So R, so this is the practice exam stuff. It's problem 3. So R is the set of all integers from 1 to 100. And T is an interesting set. So T is a set consisting of ordered triples, A, B, C. A, B, and C are real. Ooh, A, B, and C are real? Oh. I feel like he didn't mean that. Oh, no. I apologize. A, B, and C are not real. A, B, and C are elements of R. I was reading that as the real numbers, not R. And so, and then we were given that A is less than C and A is less than B. Okay. So, what's the size of T? How many things are in T? Okay. So here's what I would start doing. I'm going to start trying to count the number of things by starting at kind of a logical place. And you could, I'm not sure if it makes more sense to start with A being high or A being low. You can kind of go either way, I feel like. Let's start with A low, and then we'll think about A high. So T has things like, so at the very lowest, A could be 1. All right, if A is 1, how many choices are there for B?
Well, B is a higher number than A.
Right, so how many numbers are higher than 1?
Pretty much all of them.
And how many is that in this particular problem?
99.
Right, so there's 99 choices for B, and there's also 99 choices for C. So when A is 1, there are 99 squared choices. Right, because anything here can go with anything here. So it could be 1, 2, 2, or 1, 2, 3, or 1, 2, 4, or 1, 2, 5, all the way up to 1, 2, 99, and then we can change 2 to 3. 1, 3, 2, 1, 3, 3, 1, 3, 4, 1, 3, all the way up to 99. So each of the things that can go here compare with each of the things that can go here.
Why wouldn't it be what is it, 98%?
So both because they can be the same. Right? There's no condition about B and C being different or one of them being bigger than the other one. It would definitely be a different and more challenging question if they said A was less than B and B was less than C. That would be a little bit harder, although not a ton harder. Actually, it wouldn't be that much harder, really. We can even do it if you want. Okay, so then for the next one, A could be 2. How many choices are there for B then? Well, it can't be 1 or 2. It can be anything from 3 to 99. Or sorry, 3 to 100. I apologize. Yeah, there's 98 exactly. So there's 98 choices there, 98 choices there. So 98 squared. So I think we can start to see where this is going to go, right? When A is 3, so it looks like the size of T is going to be 99 squared when A is 1, plus 98 squared when A is 2, plus 97 squared when A is 3, all the way down to 98 squared when A is, sorry, all the way down to, apologies, sorry, all the way down to 2 squared when A is 98. If A is 98, B can be 99 or 100, and C can be 99 or 100, plus 1 squared when A is 99. And I guess you could say there are 0 things you get when A is 100, so A can't be 100. So this would be what it's equal to. And just for fun, so this is equal to 1 squared plus 2 squared plus 3 squared plus all the way to 98 squared plus 99 squared. And there's technically a formula for that you might be aware of. This is the sum from I equals 1 to 99 of I squared, which is n, what is it? N times 2 times n plus, oh my gosh, I forgot the formula. I can't write it with numbers. It's n times n plus 1 times 2n plus 1 over 6. Did we learn that one in this class? We might not. Okay. I don't really think you would expect you to like do that, but it's kind of neat. You could totally actually find the actual, oh no, he totally does write it in the notes. Kind of cool. So I don't think he expects you to know it, but there is a formula for the sum of the first of the squares of the first so many numbers. And it's n times n plus 1 times 2n plus 1 over 6. So this would be 99 times, I got out of order here, 2 times 99 plus 1 times 99 plus 1 over 6. Okay, that's kind of neat. 99 times 199 times 100. I'm not surprised he wrote it in the answers because, like, come on, he's gonna write all the things. Let's look at a different, slightly different question, just for the sake of it, because I could totally see him asking something slightly different. Sure. I'm sorry, where this is.
Use 99. I did not use the 8 values.
Well, because, so that's a fair question. I didn't want to pick B or C because there was no relationship between B and C. So I decided I was going to focus on A because I knew that both B had to be bigger than A and C had to be bigger than A. So that was kind of the way I made that choice.
So would it be fair to say that I equals A or no?
In this formula here?
Yeah.
No. So I is what's called an index here. So I is any number from 1 to n, or in this particular way I've written here, I is any number from 1 to 100. So this is really just a shorthand notation for this. This here, if I wrote it out, I starts at 1, and then I is going to be 2, and then I is going to be 3, all the way up to when I gets to the last term, which is n. Again, I wouldn't worry too much about this. It's just a very standard notation. It's something I really actually needed to write so that I can remember what the formula was. But I don't think you need to be concerned about this. Other questions? If I were doing this problem on a test, I would stop here. No, you wouldn't. Yeah, so I think now you might ask Dr. Liddell just in case he has different ideas, but I think a perfectly acceptable answer for this problem would be 1 squared plus 2 squared plus 3 squared plus ... plus all the way to 98 squared plus 99 squared. I mean, that is a legitimately good answer. I don't feel like he should be expecting you to do this other thing, but I could be mistaken. But you would have to ask him about that, to be honest. I don't feel like we learned these formulas in this class, though, so I feel like that should be out of bounds. Or I don't think we learned that in any of the 17 classes. I can't remember if we learned this in 17B is where you would have learned it if you learned it. I don't feel like we did. So I'll go back and look.
Not that formula. I think we learned about summation.
You might have learned this from, because this formula comes up when you're talking about the limit definition of the integral. So that's why he might have an expectation that you would know it. Let's look at another example that's slightly different. So let's say, in fact, the example I was mentioning before, let's say we have T, so R is the same set. It's the set from 1 to 100. And now T is the set containing triples A, B, C, such that A is less than B and B is less than C. Okay, so now things get a little more interesting. This problem might be harder than I think it is. I don't think it is, but we'll take a look. So let's start with what T is looking like. So A could be 1. If A is 1, there's a lot of choices for B. There are 99 choices for B. 99? Yeah, 99. I'm going to say 98. Because technically, I can't pick B to be 100. If B is 100, then there is no choice for C. So I'm going to say there's 98 choices for B. B can be equal to 2, 3, 4, all the way up to 99. So there's 98. I'm not saying I'm picking the number 98. I'm saying there's 98 choices here. And then, so this problem is definitely a lot harder. And here's why. Depending on what B is, C is limited. So let's pretend for a second we picked B equal to, let's say we pick B equal to 92, just for example. If B is 92, how many choices are there for C? Well, let's just count them up. 93, 94, 95, 96, 97, 98, 99, 100. 1, 2, 3, 4, 5, 6, 7, 8. Or 100 minus that number. So it looks like here, basically, whatever you choose for B, there are 100 minus that number choices for C, which is going to be a lot harder. Like this is definitely a much harder problem to actually answer. Because then, right, so yeah, I think this problem is probably beyond the realm of actually being worth asking. So, good to think about though. Interesting. Okay, better question. What if we phrased it this way instead? What if we said, and let's make the number smaller. Let's say R is a set from, let's just go 1 to 10. Let's not be quite so ridiculous. And T is now the set of, again, triples, but A is less than or equal to B, and A is less than or equal to C. So now, if A is equal to 1, how many choices are there for B? 10 choices. And for C would be the same. So when A is 1, we're going to have 10 squared choices. And when A is 2, how many choices are we going to get? Yeah, they both can be any one of the 9 remaining numbers. 2, 3, 4, 5, 6, 7, 8, 9, 10. So when A is 2, we're going to have 9 squared choices. When A is 3, we're going to have 8 squared choices, all the way down to when A is 9, we're going to have 2 squared choices. And when A is 10, we're going to have 1 squared choices. The other two are both 10. So here, our answer would be that the size of T is 1 squared plus 2 squared plus all the way to 10 squared. Which, if you're using the formula that the sum from I equals 1 to n of I squared is n times n plus 1 times 2n plus 1 over 6. This would be 10 times 10 plus 1 times 20 plus 1 all over 6, which is some number, 10 times 11 times 21 over 6. I don't know, 55 times 7, 385. Again, if it were me on a test, I would stop here. With the usual caveat that if you have time at the end, then it's okay to go back and like try to simplify your answers. But really, I would not focus on simplifying something like this until I had done everything else. You know, it's good advice in general. Okay, that's an interesting question. Which other one should we look at? It's okay if you haven't looked at the practice. I can also just pick out questions. I do see on this practice test, there are some non-probability questions as well, right? There's some equilibrium stuff. So that is also looks like it's fair game, unless you just taken a practice test from before. I don't know what he said about this upcoming test, but looking at the practice test, I would assume there's going to be probability and there's going to be some classifying equilibrium kind of things. Okay, let's look at. Sure. Ah, yes. So, in how many ways can a committee of 5? So, committee of 5. Sure, I always do the wrong number. No, okay. Committee of 5 be formed from a group of 11 people. Consisting of 4 teachers and 7 students. And then there's 4 parts. So part A, if there are no restrictions. And before I even ask myself this question, I should ask, does it matter which order I pick the 5 people in? Is the committee going to look the same if I pick you first, you second, you, me third, fourth, fifth, or the other way around?
No.
Of course. Well, I mean, yeah, it's not going to matter because the committee is going to look the same. It doesn't matter which order I put the people on the committee. So we have to remind ourselves, order does not matter, which means we are most likely thinking of the choose function. So choose function, not the permutation function. So there's no restrictions, we can pick any of the 5 people. So we're going to say, okay, well, if there's no restrictions, it's going to be 11 choose 5, which you should at least probably write out as 11 factorial over 5 factorial times 6 factorial. I would do at least that much. I probably wouldn't do more though, because doing any more, right, the next thing you could do, which is fine, would be 11 times 10 times 9 times 8 times 7 over 5 times 4 times 3 times 2 times 1. Right, I know the 6 factorial part's going to cancel out. Or I should really say, I know the bigger factorial part's going to cancel out. It always makes sense to cancel the bigger one, and then the remaining terms, there'll be 5 terms on top and 5 terms on the bottom. Always true. So just as a quick aside, this is not perm or permutation function. So for example, if I was trying to simplify 32 choose 7, which is 32 factorial over 7 factorial times, bless you, 25 factorial, I'm definitely canceling the 25 factorial part. So right at the top is 32 times 31 times 30 times 29 times 28 times 27 times 26 times 25 times 24, right? The rest of it is 25 factorial. So I know I'm going to get all the terms on top until I get to 25. And then on the bottom, I'm just going to get the 7 factorial. 7 times 6 times 5 times 4 times 3 times 2 times 1. But what I've noticed over the years is that always when you do this, the number of terms you're left with on top is exactly the number of terms in your smaller factorial. Always true. Which makes sense because it's just a difference. Again, I think leaving it like this is ideal. Part B. The committee must include exactly 2 teachers. So exactly 2 teachers. All right. Well, there are 4 teachers and we're going to choose 2 of them. So we're going to do 4 choose 2 for the 2 teachers times, well, if there's 2 teachers and we want the committee to have 5 people, there better be 3 students. So we're going to multiply that by 7 choose 3. Which 4 factorial over 2 factorial times 2 factorial times 7 factorial over 4 factorial times 3 factorial. If I was trying to simplify this, I would cancel those 4 factorials. And then over here, I'm going to have 7 times 6 times 5 times 4 on top. I'm canceling the 3 factorials times 2 times 1 times 2 times 1. That's going to be 7 times 6 is 42 times 5 is 210. But really, this is probably where we should leave the answer. So I'm trying to kind of split the difference here and both tell you not to do all the work I'm doing and then showing you all the work I'm doing anyway. It's good to know how to simplify these things in case you have to. So part C is pretty much the same question. Part C is exactly 3 teachers. So if you want exactly 3 teachers, it's going to be, now it's going to be 4 choose 3 times 7 choose 2. Which would be 4 factorial over 3 factorial times 1 factorial times 7 factorial over 2 factorial times 5 factorial. I'm going to not simplify it. Although this one would probably be the easiest one of all to simplify. He says before simplifying it, you said I wouldn't. This part here is just equal to 4. This part here is 21. Sorry, I can't help myself sometimes. So one more time, sorry. Right. So the thing you should be looking for when you're wondering what to do is this question specifically says, how many ways? So we're saying, oh, the number of ways is this many ways. The thing you're thinking of is if they ask, what's the probability of getting, so like if I said, I want to know what's the probability of picking a committee that happens to have 3 teachers and 2 students, it would be this number divided by the total number, which would be this number. So in fact, that's a good, yeah, if I want to find the probability of picking a committee with exactly 3 teachers, it is important to look for that word exactly. It would exactly be the 4 choose 3 times 7 choose 2 divided by the 11 choose 5. The number of ways of getting a committee with 3 teachers divided by the number of ways of getting a committee with any 5 people. Good question. Yeah. So, but that's the main difference between probability and just counting anything, right? Probability is just the number of ways of getting the thing, and then you divide by the total number of things that can happen. So definitely look out for how the question is asked. And now part D, a particular teacher and a particular student cannot be both in the committee.
So if it's the same thing, the probability with at least 3 teachers,
You want to do the probability or the number?
probability.
Okay, so well, we're still going to do both. So what if I wanted to find the probability of the committee having at least 3 teachers? Okay, so we're going to count the number of ways of having at least 3 teachers. So that's going to be, well, we've already done one of those, right? Having exactly 3 teachers would have been, and I'm going to use my preferred notation because it's just easier for me to write. 4 choose 3 times 7 choose 2. Right, that's having exactly 3 teachers. But then we could also have exactly 4 teachers. 4 choose 4 times 7 choose 1. That would be exactly 4 teachers. And those are the only ways we can have at least 3 teachers, right? Because there's only 4 teachers to pick from. So you're either picking 3 of them or you're picking all 4 of them. So then if we want the probability of at least 3 teachers on the committee would be exactly the number of ways of getting them. 4 choose 3 times 7 choose 2 plus 4 choose 4 times 7 choose 1 divided by our 11 choose 5. The total number of ways you could pick any 5 people out of the 11 people to be on the committee. How many teachers are there? There's only 4, right? So you're right. If there were 5 teachers, then we told, well, then first of all, it'd be 5 choose 3 times 7 choose 2, 5 choose 4 times 7 choose 1, and then it'd be 5 choose 5 times 7 choose 0. But basically, whenever you're doing the choose function, the top number has to be bigger than or equal to the bottom number. Like the bottom number in your choose function, or the second number, the thing you're choosing, you can't choose more things out of. You can't choose more things than however many things you have to choose from. I can't do 4 choose 5. There's no way to pick 5 things out of a group of 4. There aren't enough to pick. Let's look at the last one for this particular problem. A particular teacher and a particular student can't both be in the same committee. Both be in the committee. Okay, so we've got our 4 teachers. Let's call them A, B, C, and D. These are my teachers. And we've got our 7 students. Let's call them 1, 2, 3, 4, 5, 6, and 7. And we have to just decide that there's 1 teacher, 1 student pairing we can't have. So let's say teacher C and student number 4 really don't get along. Or maybe they're related and they're just not both allowed to be on the same committee. That's a better way of viewing it. So C and 4 can't be on the same committee. So how many ways can we make the committee as long as we don't want those 2 people to be together? Okay, well, it's a good question actually. How many ways can we do this? I can't just pick any 5 people, right? So I could either, how would you do this? Okay, here's what I think. So something, right? Like a lot of times I'm like, how would you do this? So here's what I'm thinking. I can either look at, so the whole group of 11 people minus teacher C. So that group has 10 people in it. And from that group of 10 people that doesn't include teacher C, I can pick any 5 of them. Because any 5 that I pick, am I thinking this the right way? Well, let's go through with it this way and then we'll see. Pun not intended. Teacher C. All right, so I'm thinking what we can do is from this group of 10, we can pick any 5. I'm worried I'm going to get some overlap. Well, we might have to go back and revisit what we're doing. And then we can also look at the same group minus student number 4. And from that group of 10 people also, there are 10 choose 5 ways we can pick any of them. But now I have a problem. And the problem is, I'm pretty sure I've counted all the ways of picking groups of 5 people that don't have C or 4 in them twice. Right? Because from this group of 10 people without C, if I pick any 5 of them, well, sometimes the 5 I pick aren't going to include 4. And if I pick, groups out of the 10 that doesn't include 4, well, sometimes the 5 of those will also include the same 5 people I already picked before. So I think what we have to do is we have to actually, it's like the intersection thing, or right when you're trying to find the union, it's A union B, it's equal to the probability of A plus the probability of B minus the probability of the intersection. I think that's what's going on here. So what I think we have to do is we have to actually subtract off 9 choose 5 for the number of ways of picking any 5 from the people that aren't C or 4. we're going to double check this, but I'm pretty sure our answer here is going to be 10 choose 5 plus 10 choose 5 minus 9 choose 5, which I think we should calculate because we're going to try and see if this is the same as doing it another way. All right, 10 choose 5 is 10 factorial. I should be smart about this. This is 2 times 10 choose 5. So 10 factorial over 5 factorial times 5 factorial minus 9 factorial over 5 factorial times 4 factorial. And let's see. So that's going to be 2 times 10 times 9 times 8 times 7 times 6 over 5 times 4 times 3 times 2 times 1 minus 9 times 8 times 7 times 6 over 4 times 3 times 2 times 1. Calculating these is never fun. I assume we're not allowed to use a calculator though, right? Probably not. Okay. So when I'm trying to calculate something like this, if I actually have to calculate it, I'm looking to cancel things as quickly as possible. So 3 times 2 times 1 is 6. 5 times 4 is 20. Cool. So I've got a 9 times 8 times 7 minus here 3 times 2 times 1 is 6, and 8 over 4 gives me a 2. So I've got 9 times 8 times 7 minus 2 times 9 times 7. And if I'm real slick, I'll factor out the 9 times 7. I'm left with 9 times 7 times 8 minus 2, which is 63 times 6, which is 360 plus 18, which is 378. I feel like that number came up earlier. Normally, I would not advocate finding this number, but we're going to check to see if there's another way to do it. So here's the other way I think you can do it. And this really does come down to just kind of how you see it. I saw it one way first. I did it that way first. So let's think of it this way. You could pick a group. So we could say, let's say that person C has to be in it. So our group contains teacher C. Okay, well, if it contains C, we can't have 4. Right, number 4. So if my committee of 5 has person C in it, and you can't have student 4, how many people are left to choose the other 4 remaining spots? As a reminder, there were a beginning of 4 teachers and 7 students. So I've got 1 teacher, I can't have 1 student. How many people are left to choose from? A few more than 6. There are 6 students, but there's also 3 teachers. 1 less. 9, right? Because we've already picked C, right? We're already saying C is in there, and we can't have this other student. So we've already eliminated. Well, we've picked 1 person, and by that choice, we've eliminated 1 other person. So for the 4 remaining spots, there are 9 people we can choose from. So if our group has C, there are 9 choose 4 ways of getting that. Similarly, if our group has person number 4, has student 4, I should say, teacher C, student 4. Well, that's going to be the same sort of thing. Student 4 is going to be in there, and then teacher C can't be in there. So there's 9 choose 4 ways of picking the remaining 4 people. And importantly, unlike the previous one, there is no overlap between these 2 groups. Right? This group, all these groups have person C in them and not person 4. All these groups have person 4 and not person C. But then I have one more thing I have to count. All the groups that don't contain either person C or person 4. So then neither C nor 4. Well, great. If I don't have either of those 2 people, there's 9 people left to choose from, and now I'm picking all 5 of the group members to be in it. So we're going to get 9 choose 4 times 2 plus 9 choose 5. And I'm pretty confident that's going to be the same. But let's do the work, because we should do the work. This is going to be 2 times 9 factorial, which is 9 times 8 times 7 times 6, divided by 5 factorial times 4 factorial. I'm trying to show a little less work here. I've already canceled out the 5 factorial that would have been on top and bottom. And then I'm going to have plus 9 times 8. Oh, I'm really smart here. Interesting. 9 choose 5 and 9 choose 4 are really the same. Let's see. Well, let's write it down. 9 times 8 times 7 times 6 times 5 times 4 times 2 times 1 over. Right. I can cancel out the 4, 3, 2, 1. I can also cancel out the 5. Oh, look, that, oops, the 5, not the 4, James. The 4 is still there. This part here and this part here, exactly the same as those parts there. This is really equal to 3 times 9 times 8 times 7 times 6 over 4 times 3 times 2 times 1. Cancel some stuff. So now I'm left with, oh, look, 3 times 2 times 9 times 7. It's exactly what we had before. Which way is better? That's a trick question. Neither of the ways are necessarily better. I mean, it wasn't on purpose a trick question. But really, so in my mind, I feel like the second way I did this was the easier way to understand. I feel like doing it this first way, it'd be really easy to miss the fact that you have to subtract off the overlap. Whereas doing it this way, where you say, okay, I either make a committee that has to have person C, or I make a committee that has to have teacher 4. Sorry, I got the names. Teacher C, student 4, or I make a committee that has neither of them. I feel like that's probably the easier way to actually approach this question. Both approaches are correct. I don't have a good answer as to what's better, other than what I feel like is better for me. Questions or observations? I saw one here that looked interesting, but not too terrible. Between 20,000 and 70,000, how many even integers are there in which no digit is repeated? Okay. So I would probably break this up into 4 different sub problems. The first problem being 5-digit numbers that start with 2. 5-digit numbers that start with 3. 5-digit numbers that start with 4, and maybe 5 problems, not 4 problems. Start with 5 and start with 6. Okay. What are the even digits? They are 2, 4, 6, 8. Is that all of them? Not all of them. There's also 0. 0 is an even number, right? It's divisible by 2, just like every other even number. It's also between 2 odd numbers, just like every other even number. So we want to not repeat any integers, any digits. So how many choices are there for this? Well, really, we should go with the last spot here. Because to be an even number, the last spot has to be even. Let me say that again. To be an even number, the last spot has to be even. So how many choices do I have to go in this last spot here? Well, normal, I would say that's true here. There's definitely 5 choices here. But here I can't put what number? I can't put 2. So there's 4 choices there. And I'm not writing the number, I'm writing the number of choices. So I should do it like that. Okay. So I've used up 2. I've used up another even number. So there's 3 even numbers left, and there's all the odd numbers left, right? There's 5 odd digits, because any of the other digits can be odd. So it looks like there could be 8 choices for this spot, and then 7 choices for this spot, and then 6 choices for that spot. Well, because I've already used up, I used up 2, and I used up another even number. So I've already used up 2, and take your pick of any of those 3, any of those 4, sorry. Let's say the last one was 8. Then there's 1, 2, 3, 4, 5, 6, 7, 8 numbers left to choose from. I pick one of them, great, now there's 7 left. I pick another one, now there's 6 left. It's going to be different here. So for this number here, right, there are 5 choices for my last one instead of 4, right? Because that 3 is my leading digit. I can pick any of the even numbers to go here, 2, 4, 6, 8, or 0. All right, so how many numbers have I used up so far? I used up a 3, and I used up some even number. So how many choices do I have left? 8 again. Okay. This one here is going to look exactly like that one there. I have 4 choices for the last digit because I've already used up one of the even numbers. And I know the way I'm writing this might not be the most helpful, in that number there represents the number of choices, and that number there is the number you're starting with. So we're starting with the idea. And then we've used up 4, we used up something that isn't 4, like 0, 2, 6, or 8. And then we have 8 choices, 7 choices, 6 choices. And then starting with 5, it's going to be more like starting with 3. There are 5 choices for the even number we end with. 8, 7, 6. Starting with 6, there are 4 choices. 8, 7, 6. So my answer would be 8 times 7 times 6 times 4 plus 8 times 7 times 6 times 5 plus another 8 times 7 times 6 times 4 plus another 8 times 7 times 6 times 5 plus another 8 times 7 times 6 times 4. I think that should be the answer. Let's look at the solutions. I'm interested to know how he would find about this. Okay, well, it's very different than what I did. I guess it's the same. He just is a little, okay, that's fair. I like that. He did it a little bit differently, but pretty much the same. He said, okay, I've got numbers like, I've got 5 slots, A, B, C, D, and E. And the first slot there has to be either 2, 3, 4, 5, or 6. And then the last slot there has to be 0, 2, 4, 6, or 8. And so he considers 2 cases. He says the first case, well, what if A is one of these even numbers? So A could be 2, 4, or 6. Well, if A is even, then we've used up one of these numbers over here. So there's only 4 choices, and 8 times 7 times 6. So we're going to have 3 ways A could be even, 4 choices for the last digit, 8 times 7 times 6. That's exactly what we're getting right there. And then if A is odd, like 3 or 5, well, there's 2 ways A can be odd. And then there are going to be 5 choices for the last slot, and then 8 times 7 times 6. Exactly what we got. Maybe a little bit different way of getting there, but not much really.
Does it say 8 times what?
Which part? Down there?
No, I think that I is the
Probably not.
Then like I parentheses, I don't know.
I'm
One parentheses, I have no clue what that is.
lim-
But I was trying to see what the, it's just, oh, okay, is even. That's what it says,
A is even. Yes, A is even. Sorry, I know my. So A is even 2, 4, or 6. A is odd 3 or 5. I did this 2 o'clock, so I should stop doing things. As in previous exam weeks, class on Friday is optional. You're certainly welcome and encouraged to come, but if you don't want to come because studying right before your test does not work for you, I totally get that. We can do whatever you want on Friday. More review, other things. I mean, I would imagine you'd want to do review if you came, but if you really want to do something else, we can do that too. All right. So good question. Why didn't I even think about the 7? Well, because if my number is between 20,000 and 70,000, the only number that can start with 7 is 70,000, and that has repeated digits. Fair question, though.